Hello, one. So this is the number 22 for the 10B and number 16 for the 12B. So this is also another classic problem that we see like a lot. And 16 people will be partitioned into four indistinguishable four-person groups. So let's highlight this one. And each committee will have one chairman, chairperson, and a secretary as well. Okay. And the number of different ways to make this is 3 to the r times m, and then r and m positive integers. So m is not divisible by, like basically, we'd like to know what is the largest number of threes that we can multiply in our answer. Okay, so it might be a bit big numbers, which is probably why we just need the number of threes. The first thing is, there are a couple of ways like we can try this problem, but I'll try to kind of approach it with like easy way or general way. So you want to make a four people, like let's say you want to choose four people out of 16, right? So that's the number of ways you can do that. As soon as you decide the four people, you need another four for this next group. So that's gonna be 12 choose four. And then the same reasoning, we have eight people left. I need four people for the next group. And the last will be just determined immediately, which is four choose four, but you don't need that. But now I'll say for anyway, four choose four. But we are told the groups are not distinguishable. But when you do it this way, you're actually counting where those groups are kind of distinguishable. So which is why we need to fix this over counting by dividing by the number of ways that four groups can be arranged, which is 4 factorial ways. So which needs to be multiplied by 1 over 4 factorial. So we can get fixed over counting. And this is the way that we can make these groups. But after we made those groups, we need one person for chairperson and then a secretary. So let's think about the one group. So we have like four options for the person to be chairperson. As soon as we decide that person, we now have three options for the second person. But this is for one group. So we have four groups. We have this four times. So we need to multiply. And then as soon as we simplify this multiplication, we should be done. But we don't want to multiply a lot of stuff if we need to. So just remember n choose r. Like we can do this couple of ways, but the one of the ways was like, which is the definition, is n factorial over n minus r factorial times r factorial. Okay, so this is the case. So for the first one, like 16 factorial over 16 minus 4, which is 12 factorial, times 4 factorial, times 12 factorial over 12 minus 4, which is 8 factorial, times 4 factorial. And the next one is 8 factorial over 8 minus 4, which is 4 factorial, times 4 factorial. The next one is just 1. And then this is 4 factorial. I'm going to leave it as it is. Times of 4 to the 4th power and 3 to the 4th power. Okay, so we know 12 and 12 will cancel. 8 and 8 will cancel. So we don't want to multiply these either. So we have 16 factorial. Now we have a bunch of other numbers right here as well as the denominator. So I'm going to write this way. So we have 16 factorial. And then this is 2 squared to the 4th, which is 2 to the 8th power. And then times 3 to the 4th power. And I just like to write the prime factorization because what I kind of need is the number of threes. So 4 factorial has like 1 4. This has 1 4, 1 4. So we have 5 fours. So I can write 4 to the 5th power or 2 to the 8th power. And then I have 3 for each as well. So 3 to the 5th power. And then you got 2 to the 5th power because every 4 factorial has 1, 2 as well. So we have 3 to the 4th and 3 to the 5th. So these will cancel. And like, we already have 8 2s. And like I can cancel these 1. So that should be 2 to the 3rd power, which is 8 left over. So 16 factorial has a lot of 2's, which means we have more 2's than this number has. So which is why those 2's will cancel, which I don't really need actual value. So what I have left with 16 factorial, 8 and 3 in the denominator, as well as 4 to the 5th. So let me write this one more time. 16 factorial, 8 over 2 to the 10 times 3. So we have three 2's, and then you can cancel those. You will get 7 left 2's in the denominator, but 16 factorial has a lot of 2's, more than 7, so those cancel as well. So we just need to know how many 3's do we have in the 16 factorial, which we can use our floor notation. 16 to like divide by 3. When you divide, that will be like 5 point something, which means there is like 5 multiple of 3. Uh, like we have like 3, 6, 9, like all the way to the 15. But 9 has like more than 1 3's, which is why we just divide 16 by 3 square as well, which is gonna be just 1 more. So it should be 5 plus 1. So that is 6, meaning that we have 6 3's in 16 factorial. So which looks like 3 to the 6th power times something. Okay. And then, the 8 and this will cancel. Maybe I should say that something is just our m, because problem said that way. And then divide by 3 to the 1st power. So we cancel one of these 3's as well. So you get 3 to the 5th times m. So the m has to be 5. So the m doesn't really matter, which is why they are not interested. So if you kind of want to find it, you may, but you don't really need it because 16 factorial is kind of big number anyway. So that was number 22. I hope that was clear. Let's see the next one.